Hi, everyone. Welcome to this session. We're excited to have you join us. Please feel free to use the chat tab or just use the chat overall to ask your questions and share your thoughts. Without further ado, it is my wonderful pleasure to introduce you to Naty and Jacob. Let's give a warm welcome, virtual welcome to the speakers and take it from here.
Awesome. Thank you very much.
Welcome.
Let me just share my screen.
Awesome.
So thank you for coming along. My name is Jacob Tomlinson. I work at NVIDIA and work in a group called Rapids. And we're going to be talking a bunch about Rapids and specifically about like deploying GPU workloads in various environments. I've also got Naty with me. I don't know if you want to introduce yourself, Naty.
Hi, everyone. I'm Naty. I work with Jacob in the Rapids deployment team. And then I'm going to be here today also supporting your questions in the chat or interrupting Jacob if you all have amazing questions and then we want him to answer it.
Awesome. Perfect. So yeah, I want lots of like engagement in the chat. Hopefully all are starting to get, familiar with the Meet type stuff. There's a chat, there's a Q&A thing. I might do some polls. And like most critically, at the bottom of the list of tabs on the right-hand side, there's a resources page. It's got like a little like file icon. Under there, there's one link at the moment to the tutorial material itself that we're going to be running through. So you might want to head over there and get that loaded up. But just to kind of kick off and tell you a little bit about kind of who we are and what we work on. We work in this group called Rapids, and Rapids is like a set of open source libraries that you'll find in the PyData ecosystem. And the goal of all the Rapids libraries is to provide GPU acceleration to kind of everything within the like PyData suite. So whatever you're trying to do in terms of like data frame manipulation, machine learning, training models, serving, any kind of ETL, pre-processing, and it doesn't really matter what libraries you like to use, whether it's like pandas or polars or scikit-learn or whatever. We're trying to integrate into like all those different places. So we either do that by like contributing directly upstream to those projects. We have like a whole bunch of people working in NVIDIA that are like already part of this community, right? Part of the PyData community, are maintainers in various projects. And we like contribute stuff upstream, or sometimes it's not the right thing to do to put this code upstream. So we might write like a plugin or an extension or some kind of tool that will wrap around one of these libraries that gives you like GPU acceleration so that ideally your workloads run faster or they run cheaper or both, whatever we can do to kind of speed up your work. So you can find a load about us by going to rapids.ai. This is the page that I'm sharing at the moment. You can also go and find our GitHub page. It's just github.com/rapidsai, which I think is linked from here. Open this one up. You can go and see like all the various projects that we have on GitHub. You can come and engage with us and interact there, either to consume the libraries or open issues, open pull requests, whatever. We're an open community. And the goal of this tutorial for PyData Global is to focus on what does it take to deploy GPU accelerated Python applications. Right, we spend a lot of time in our team thinking about cloud deployments, HPC deployments, like wherever it is you're trying to actually run this workload. But like before we jump straight into that, let's like start at like just with a little demo of kind of what we do in Rapids. What we're going to cover in the main tutorial is kind of Rapids and beyond. Right, it doesn't matter what kind of GPU workload you're running, but just to show you an example of what we can kind of do. I'm just going to head over to this tutorial. This is on GitHub, the Rapids AI community tutorial page. And there's like a whole bunch of different examples in here of using different Rapids libraries. And the one we're going to start with is this Intro to QDF notebook. Now, I'm going to show you this. I'm not necessarily saying like you should run through this right now. You can. It's just a Colab notebook, and you can sign up for Google Colab and open that. Everything we're going to be doing in this tutorial is going to be on a different platform. But I just kind of want to show you this because one of the nice things about Colab is it provides a lot of stuff out of the box. So if I open up this notebook in Google Colab, you can see up here, I've got the runtime. And my runtime type at the moment is selected as an NVIDIA T4 GPU. This is in the free tier of Colab. And you can kind of use this within Google's fair use policy. So I can run through this notebook. And Colab also has a whole bunch of libraries pre-installed in this environment, including a load of Rapids libraries. So just to show you a quick example, we can wget this little setup script that's going to download some data for us. And this is a little pandas workload. So this is using a library that we have called cuDF. This is the CUDA data frame library. You can use cuDF in a couple of different ways. One kind of directly. It has this API that's designed to mimic the pandas API. But we also have this we call it like the zero code change mode, which is the mode where you can just use pandas and cuDF behave like a plugin basically, and lets you speed things up. So one of the first things I'm just going to run in here is this NVIDIA SMI command, which is going to just show me that, yep, I have a GPU. It's got 16 gig of GPU memory, and we can do some things with it. Now, when I ran this data setup script here that we just pulled down, this downloaded a Parquet file, which has got some open New York City data. This is about parking violations in New York City. But to run this, if I want to do some normal pandas code, right, I can import pandas as PD. I can do pd.read Parquet, and I can do kind of all these normal operations that I would want to do. Now, if we want to GPU accelerate this, if I've got this code in a script, I'm going to run my pandas script here with Python, in the path to the script. If I want to GPU accelerate this with the cuDF plugin, we can just do python-m cuDF.pandas and the script. We don't need to edit any of the pandas code. It will just execute on the GPU instead of the CPU. And it does this opportunistically, right? So there might not be like a 100% coverage, every single thing works in cuDF, or maybe there's some issues where like your data will fit into main memory on your system, but it won't fit into the GPU memory on your system. Whatever the kind of failure mode you might run into with these tools, it will just fall back to the CPU. So the worst case scenario is just that it runs with normal pandas, but ideally it's going to GPU accelerate everywhere that it can. Now, we got this script way of running things, but in a notebook environment, we also have this notebook way of running things. So we can do this %load extension cuDF.pandas. And then whatever we do after this point, once we've imported pandas, we'll be using cuDF under the hood to do that acceleration. So I'm going to import pandas first. And then when I run this first command, it's going to do this pd.read Parquet call, and this read is going to have been done onto the GPU. This data frame now is loaded, but it's in GPU memory. And we could do all sorts of little operations in here, like we could say, oh, I want to do a group by on my data frame by the state that people are from, where their vehicle is registered, to see like which vehicles from which states get the most parking violations. I would guess in New York City it will be states close to New York. But you can see here that this operation was very, very fast, right? It took a few seconds to run. And compared to the pandas code, this will be much faster, which can take kind of minutes for the same kind of operation. I think also when I first ran that, it suffered a little bit of like startup lag. So probably if I run this again, it'll go a lot faster. Yeah, 66 milliseconds. When you first start things on the GPU, it has to populate the GPU with a whole bunch of things. So there's a whole bunch of stuff in this tutorial, and this isn't like the point of what we want to show in this tutorial today, but I kind of wanted to just highlight like we've got all of these libraries that let you use GPUs to do GPU acceleration, and we teach these tutorials frequently at various conferences. You can go and find recordings online. All this material is on GitHub, so if you want to run through this another time, take note of this URL, this Rapids community /tutorial. There's a whole bunch of notebooks in here that will show you some cuDF examples, some QML examples, some pandas work, some scikit-learn work, some polars, and all sorts of different things in there. But what we want to try and do today is we often get asked at these tutorials, like, how do we get this compute environment, right? How do we actually install and run this in the place that I want to run things? Because I probably don't work in Colab all the time as my primary environment. You may use any number of cloud platforms, or you might have a local compute cluster, or you have access to wherever it is your organization wants to get you GPU access. And so there's lots of different ways that you can install these things. There's lots of different ways you can set up And so we're going to run through some like kind of basics, almost like admin type things to getting to this point where we can run some code that uses the GPU from Python. So to jump over to the material for today, everything we're doing is in this repo, right? This is called the Accelerated Computing Hub. This is an open GitHub repo that we have on the NVIDIA GitHub organization, and it's just full of all sorts of different tutorials and different material, right? There's like C++ tutorials in here, Python tutorials that dig quite deep into all of these libraries. You can do kind of CUDA kernel authoring in Python or in C++, or you can do high-level work as well. But we have this GPU deployment tutorial as well, which is the latest thing that we've added here. And this is what's linked in the sidebar. So to run through all the material today, we are going to be doing everything in this platform that we have called NVIDIA Brev. Right? Brev is our kind of managed portal on top of other cloud providers that kind of just simplifies launching GPU workloads. So what I'm going to need you all to do to follow along with this, if you want to, is to go to brev.nvidia.com and sign up for a new account. Just use your personal email, your work email, whatever. Go and sign up for an account and log in. You don't have to put any credit card details or anything in. Just go and sign up, and it'll probably email you, and you have to confirm the thing in the email. Anybody who's watching live, follow along with what I'm doing. Anybody that's watching the recording of this session, you can also just follow along with this. It'll work exactly the same. Because the way we're going to do this is we're going to give you a coupon code that will get you enough credit to run through the material that we've got today. So when you go and log into Brev, you should be greeted with a page that looks a bit like this one. You sign up and log in, and there you go. This is the homepage that you should end up on once you're logged in. But you may have, I'm logged into my account, which has already got some credit on it. But it may say like a random string up in the top right corner here where it says Rapids deployment on mine, or it might have it might say unknown or undefined, something missing. If it says undefined or unknown or anything like that, make sure you kind of click on this and create a new organization with this new organization button. You need to have an organization because that's where the credit gets attached to. You just fill in like a random name, whatever you want it to be called. Then the next thing you need to do is go to the billing tab. And then down under here, there's like a redeem code button in the middle where it says pay, in this pay for compute section, you can click redeem code and enter a code. Now the code for the session today is PyData-Global-2025. I'm going to put it in the chat in AirMeet. I'm also just going to paste it in on the screen so you can see this in front of me. So it says PyData-Global-2025. And if you click redeem on this one, I've already used this code, I think, to test it out. So it's told me that I've reached my maximum number of times. You can only use this code once, but what it should do is give you a balance of $3, add $3 to your account. Now, if you have any trouble getting set up with any of that, please do mention in the chat. Natty can help you kind of synchronously, or if lots of people are running into issues, Natty can ping me and we can kind of talk about it as a group. But we're going to get to this point where you're logged in, you've got an organization, you've got a few dollars of credit, and you can see this page that says GPU instances. I've clicked this GPU tab in the top right-hand corner. What I might do is, Natty just said, can we get a thumbs up if you're able to redeem the code in Brev? What I'm going to do is I'm going to do a poll. It says create a poll. Can you apply your credit in Brev? Or have you? Have you applied? I'm going to press publish. Let's see what happens. Show poll on stage. Cool. Okay, so you should be able to click that if you are following along with this. Okay, I'm seeing a few people saying yes, and one person saying no. The person who said no, if you're having any trouble with it, please do comment in the chat and we can help you. For the people who've replied yes, that's good. What I'm going to do then, I'm going to keep moving through the steps and show the next little stage because most people seem to be getting there. So I'm going to hide that again. Right, create new instance. When you click create new instance, it shows you like a whole bunch of different GPUs, right? These are kind of all the different GPUs that you can get from NVIDIA on various different cloud platforms. For the purpose of this tutorial, it doesn't really matter which one we use. What we're going to do is just pick something that's pretty modern and pretty inexpensive. So I'm going to choose the L4 here. But you could equally use like a T4 or an L40S. But we were warned maybe that we could run out of some capacity on these. So if we do run out of L4s, I would encourage you all to click L4 and choose an L4. But if we run out of capacity, you can pick one of the others as well. And I'm also going to say, make sure you click on the GCP option here. Now, there's like different options from different providers. There's AWS, Scaleway, like a whole different bunch of different folks in here. But we've only tested the material on the GCP instance. There's like slight differences in the operating system image that you get from each one, which doesn't really matter if you're using containers or something, but like we're going to tinker around in the operating system. So we've tested this on GCP. Please all click on the GCP option so that we're all in a consistent environment. Once you click that, it then asks you like how much storage do you want. I'm just going to leave that as the default, like 256 gig is fine. And I'm going to set the name. I'm just going to call it like, yeah, my name, tutorial demo or something, but call it whatever you like. There's also like a little advanced section, which you can choose different things. And then there's this little kind of dashed box here that says VM mode with Jupyter. Now that is the mode we're going to use. We're not going to change anything here. Just in case you're curious, if you click it, it gives you like a whole load of other options to say like, oh, I want to run a container or do some Docker stuff, or I want to run Kubernetes, whatever. We're going to leave it in VM mode. And we are going to leave it with install Jupyter on host toggled on. Okay, that's just the default. I'm not going to touch anything else. I'm going to click deploy. Now, once I click this, like a couple of things are going to happen. Right, we're going to see this. There's one blue box at the top that says deploying. Right, so this is calling out to Google Cloud, provisioning a brand new VM, and kind of getting the infrastructure ready from the cloud, whoever you've requested that from. Once it goes from deploying into running, Brev is then going to start up some additional setup steps for us. And so this other box down the bottom that says waiting, that will go into, I think it says building for a little while and then running. So we're gonna wait for this to run. In the meantime, the way that I'm going to access this instance is via SSH because we're going to do a bunch of stuff on the terminal. We can also access it via Jupyter. And if you're familiar with Jupyter notebooks, then that would be a good place for you to come in and work. But I like doing stuff over SSH. And there's a nice Brev tool that makes kind of SSH into things very, very easily. So because I'm on macOS, it will be telling me to brew install the Brev command line tool. If you're on Windows, it will tell you some other command, and Linux, it's got these different commands for different operating systems. So click that command and run it on your machine to install this tool. It's not a very, it's quite a lightweight tool. And then once you've run that, there's this Brev login command, and if you click this, it usually gives you like a token as well. Let's see. If I just come and do Brev login, oh, that's weird. When I ran and tested this the other day, it said Brev login -- token and some token that gets copied. So if that's not there, maybe there's some other way. Yeah, okay, it's there. I can see. If you click, there's a little J up in the top right for me because my name's Jacob. If you click that, you get a drop-down box with a few options. One of them says install CLI. If I click that, it then has this option of login via CLI, and it says Brev token -- and some stars. And if I click copy on that, and then go back to my terminal and paste that, I get some big, long, gnarly token. Hopefully that token expires nice and quickly, and it will get me logged in. Now, if I then do Brev ls, I can see I've got my VM that's starting up here, J Tomlinson tutorial demo. Status is running.
You're not sharing your terminal.
Oh no, I just did screen sharing. Let me try that again. Yeah. Share, window, that window, share. Okay, can you see the terminal now?
It's a little small. If you can make
Okay.
it a little bigger.
Yeah, let's make that bigger.
Yep.
Okay.
This would be maybe a good point to ask. Like, are people about in here, or are people following behind? Because there were some questions. I think like some might be fall in the Brev CLI part. So
Yeah. Okay. So that for people in the chat, yeah, the redemption code is in the chat. It's PyData Global 2025. I can go back to that though. If you click billing up in the top here on Brev, there's this button in the middle that says redeem code. And if you click that, you can paste the code in here that's over in the chat. I'll paste it in again just so you can see it in the screen share as well. There it is, PyData-Global-2025. So you run that, click redeem. I've already redeemed it, so it'll complain at me, but you should be able to redeem that and get some credit. Then once you've got some credit, we went in, clicked new instance. We picked an inexpensive GPU, doesn't really matter what, anything that's kind of less than $1 an hour. I chose an L4. It's got 24 gig of RAM, but you could pick like an A10 or an L40S. These are all kind of around $1. The only limitation is we want to choose something from GCP because we've tested that. So we know that the L4 on GCP works for what we're doing. You could also pick T4 on GCP. It's half the price, a bit less RAM. Doesn't really matter at all. Right? I chose L4. Once I chose that, I then just gave it a name and clicked deploy. And if I go back to my tab, I can see my instances here.
yeah, now we only see your terminal. So
what?
I think it's not sharing full on screen. It's just sharing one of the tabs.
Entire screen. Let's try this. Third time lucky. Right.
Okay.
You can see the browser. Yeah?
Yeah.
And then you can see the terminal if I do that.
Yes.
Yay.
Perfect.
Okay. Okay. Just took 3 times. Right. Let me just show that one more time then. So billing, redeem code, paste the code in there. Then over to GPUs, create new instance, choose an L4 on GCP, give it a name, click deploy. Okay, and then if I go back to the GPUs tab, I can see my VM. I'm now in like a running state, and my status still says building, right? So building is those kind of other options, right? We just chose give me a better VM with Jupyter, so this is probably just installing Jupyter. You could have said pull a container or install Kubernetes or do a whole bunch of other exciting things, but we're just going to keep it simple. And then, yeah, when I logged into the terminal, I clicked up on my name up here, clicked install CLI, and then there's a couple of commands here, one to install the command line tool and one to log in with a token. It's started out in the browser, but if you click copy, it copies the full token. So if I come back to my terminal now, if I do brev ls, it shows me the same kind of list of things. But I should also be able to do brev shell and the name of my instance, and it will say waiting for instance to be ready. It's probably just probing it. And then once it is ready, it will log me in and drop me into a bash shell on the machine. Okay, here I am in the machine. So I am on this one. If I do uptime, I can just see it's been up for 4 minutes. Equally, if you come back and this has failed. After a good start here, I've not seen it do that before. Let's see if it be interesting to see if any of you get that or whether mine's just been a bit strange. Anyway, we don't really need it. We can just run through and go through some of this. So let me now head back to the material. So this is the GPU deployment guide material. This is linked in the resources in AirMeet. So that's the bottom tab, the little file. You can open this one up, and I'm going to start going through some of the instructions here. So we've kind of done all of this stuff already. I'm logged in. The first instruction here we're going to do is just a cat etcos release, so we can see what kind of machine we're on. We're on a Ubuntu 22.04 machine. And I think the next thing it tells us to do is to run NVIDIA SMI on here. this is like the NVIDIA SMI is like the hello world of anything to do with GPU compute. Basically, it's the show me my GPU setup. So we run this, we can see I have one GPU. It has an index of 0. That's its name. It's an L4. It's got 24 gig of memory, and we're not doing anything yet. No processes are running. But this tool is very useful, and it will tell us all sorts of different things about our setup. Okay, I'm just having a look at the chat. There's a couple of questions just saying it can't keep up with all the talking. So everything that I'm saying is here in these instructions, right? In AirMeet. So it's this page here, Accelerated Computing Hub. Go and open that one up, and kind of if you miss anything that I say as we run through, then you can kind of follow along with the instructions in there. So what I'm going to start out by doing is I'm just going to say, yeah, we're going to use pip to install some stuff. And we're going to kind of intentionally immediately fall into some traps to show you some of the challenges around setting up some of these things. So this basic Ubuntu VM has Python installed. We're not going to do anything kind of clever with it. We're just going to pip install CuPy. Now, when I ran NVIDIA SMI, it showed us that we have CUDA version 12.8. Now, there is like a little limitation with the way that Python packaging works, is that we need to pull the right version of the package for the right CUDA version, but pip doesn't know anything about CUDA. So we have to specify, don't know why I didn't copy that. We have to specify exactly in the package name which version we want. So we're going to pip install CuPy CUDA 12x. Right? There's also 11x, 13x. You get the idea. We're on it. We have CUDA 12 on this machine, so we're going to install CuPy CUDA 12x onto here.
Do you want to make this terminal bigger?
I can, yeah.
There we go.
Cool. Okay. Now I'm going to start Python 3, which will just start me up into an interactive shell. And I'm going to import CuPy and just try and do some things. So CuPy is the CUDA accelerated implementation of NumPy. So the API in CuPy is exactly like NumPy. If you've used NumPy before, everything should feel pretty familiar in here. So what we're going to do is we're just going to import CuPy as CP. We're going to create a new array of just a few elements. This isn't a good use of a GPU, but let's create an array with a few elements in, and then we'll just square all those numbers. If I run this, I immediately get a traceback. Now, I wanted to show you this because this is like the most common error people see when they're first starting out, and it can be slightly unpleasant. And there's a whole bunch of reasons why this kind of thing can happen. But just to highlight that the problem that's come up here is it says OS error, libmvrtc.so12 cannot open shared object file. Now, if you're not experienced with kind of compiled C dependencies in the Python ecosystem, what this is basically telling us is there is a dependency called libmvrtc, which it can't find. This is a bit like an import error in Python, except this is like an import error at the C level. Right? CuPy is trying to import some C extensions, and it can't find this file, libmvrtc. Now, this is part of the CUDA toolkit. So what we kind of want to show you in this tutorial is that there's a whole stack of software that starts from the NVIDIA driver. Let me drop out of here and just run NVIDIA SMI again, so we can talk about this. So when this box started up, it's got a GPU in, and Google Cloud kindly gave us the NVIDIA driver. So the driver is installed, right? The driver version is 570. Whatever it is. And this is just to allow the Linux kernel to talk to the GPU hardware. That's all the driver does, is handles that communication. If we want to run code, run applications against that, we need to be able to talk to the Linux kernel, talk to those driver extensions. And on NVIDIA GPUs, we do all of this through CUDA, right? CUDA can be a little bit of an overloaded term. It kind of refers to a language, it refers to runtime, it refers to some libraries. It's like a whole bunch of stuff. But what you need to know really is that when you have a GPU, you have your driver installed. That driver can support certain versions of CUDA. Specifically, this driver can support CUDA 12.8. On top of that, on top of the driver, we need to have a whole bunch of libraries, right, that allows us to interact with the GPU and run code on it. And we call this the CUDA toolkit, right? This is like a whole collection of all sorts of different libraries. This might be kind of really basic libraries for just generating random numbers, or stuff a bit like libc if you've done C or C++ kind of programming. This is low level, basic functionality. And then there's a whole other bunch of libraries in there as well, like QFFT and all sorts, like all these kind of higher level libraries that have abstractions for doing different operations. So we have a driver out of the box here, and we have a supported CUDA version, but we don't have CUDA toolkit. This is what CuPy is complaining about. It's saying I can't find the NVIDIA runtime because I don't have CUDA toolkit. So there's a few different ways that we can fix this through various different package managers, and we're going to kind of explore those different options. But I just we're coming at this from this kind of slightly harder angle, because in the most basic Python setup, where you just use pip, which is not like a fully featured package manager, it's easy to run into these kind of challenges. Now, all of these libraries that we're expecting to find that are part of CUDA toolkit live in this path called user local CUDA. Right? So if we just ls user local CUDA, we can see like it's just missing. Right? We don't have a user local CUDA. And so what I'm going to do is we're going to start trying to fix this pip situation before we move on to other things. So because pip can't handle any other dependencies other than Python dependencies, we're going to have to use another package manager to install the CUDA toolkit. And given that we're on a Ubuntu machine, we're going to use apt or apt-get to install this. So the first thing we need to do is add the NVIDIA apt repository so that we can pull code from there. This code is just taken from the like CUDA getting started documentation. So we've installed this thing called CUDA keyring. It's just got the public key of the repository and the repository file, so that we can then pull. So you can see this hit one here from pulling from NVIDIA, and there's also this developer.download.nvidia repo. And then once we've done that, we can do apt install CUDA toolkit 12.8. Now again, we need to be explicit and say, right, our driver came with 12.8, so we need the 12.8 version of CUDA toolkit. And this will take a little while. And this is running through and pulling down a whole bunch of stuff. But we can see some of the libraries that are coming in here. Right, there's CUDA GDB. This is the debugger that you would use for writing C code. There's MVProf, which is a profiling tool. There's there's the runtime and the device driver developer header files and all these kind of stuff that as a Python developer you shouldn't really want to care about these things. These are this is stuff that the people writing the C++ code underneath all of your favorite libraries like QDF or PyTorch or JAX or whatever, right? They'll have been writing against these libraries, but these are compiled dependencies, and we're installing them with apt. Here's libcublast, right, or the linear algebra stuff that we're going to use in a whole bunch of different libraries, scikit-learn and NumPy and wherever. So while that's installing, let's keep having a look through our instructions. Let's see if there's anything in the chat, in the Q&A. Okay. If you have any questions or you're not following along, then please do comment and ask more questions in the chat. If you are watching the replay of this, by the way, obviously skip back and run forward over other steps. But if not, you can also head over to our developer forums and contact us there. One good way to contact us is just this Accelerated Computing Hub repo. Like if you really find a problem with the material or if there's anything that you're running into, please don't hesitate to open an issue here. Mention that this is the GPU deployment tutorial, and open an issue on there. And Natty and I will be able to see that. So once we've installed all of this, we should then be able to do our CuPy code again. It's still going, still thinking about it. So I guess it's worth saying, like installing the CUDA toolkit like this is bringing in like everything. The CUDA toolkit is a large collection of many, many packages We don't need all of them for what we're trying to do with CuPy in this tiny example. You won't need all of them for using PyTorch or whatever, but it's just that it's a complete collection. And when you're trying to do stuff in like a pip type environment, is the easiest thing to do is to just install all of CUDA Toolkit. You may end up in other environments, say you're using Colab or you're using Databricks or Snowflake or another kind of managed platform that does this stuff for you. They will probably have installed all of this for you, and you'll find that at this user local CUDA location. So if you're using GPUs anywhere, you can go and have a look in there and see which version of CUDA Toolkit that you might get. A common issue that we often run into is that maybe your CUDA toolkit doesn't match your driver version or something. If you have CUDA toolkit in like a pre-baked environment and then you upgrade your driver or something, you might get out of sync. I can see someone in the chat saying I was following and moving ahead, but now I'm just installing CUDA toolkit. Yeah, this step does take a little minute just to run through. I think mine's nearly at the end now. There's just a few big things to unpack. This is probably just spending a lot of time unzipping files now. We'll see another way of doing this in a little bit that is a much more lightweight than what we're doing now. But for completeness, we're kind of showing you everything. One other thing that we are trying to do at the moment as part of, we have like a whole group working on packaging within the Python space. And we're trying to improve a lot of this setup. So ideally, you would be able to get these things through pip. There's a whole project going on at the moment within the Python kind of core community called wheelNext, which is kind of intended to be the next version of Python wheels, which will be a bit more intelligent and will be able to understand things about their environment. And that would allow us to then package up all these individual components as like pip installable packages, and then libraries like PyTorch and CuPy and things would be able to depend on those directly, and that would be in a much better place with packaging if the Python tools could do all of this. I feel like this is going a lot slower than the last time that I ran this.
Yeah. It happened to me too yesterday. It's because the last step that is also doing the install is there.
Okay. Right. Skip through a bunch.
I saw that bunch of people join kind of like in the last 10-ish minutes.
Okay.
I just posted on the chat. They can catch up and follow along, and the redeem code is in the chat too.
Yeah, okay, that's great. I mean, for those people that have just come in, maybe you've come in from another session, we're following along with the material that Natty linked. We're logged into Brev, right, which is this NVIDIA platform that we have. If you want to get caught up, you can come here. You can, once you've signed up, just create a free account. Make sure you have an org up in the top corner. Mine says Rapids Deployment. Yours may say unknown, or it may say a random number. If it says a random number, that's fine. You've just got a default org. But if it doesn't, if it says unknown or something, create a new one. But then you can click billing and then go redeem code in this middle box here and put in the code that Natty put in the chat. And that'll give you a few credits for you to come and launch a GPU and follow along. You then go up to this GPUs tab and say create new instance. It gives you a whole bunch of different instances to choose from. We've recommended that you choose the L4 from Google Cloud, just because that's exactly the same one that we're using. If this does run out for some reason, you could also get a T4 from Google Cloud as well. It would just be a consistent software environment for us to all work through together, and they're quite inexpensive, so it would allow you to get the most out of your credit. So once you launch that, you click on it and give it a name and click deploy. And then once it takes you to this page, and then there's some instructions here on how to like get an SSH shell into that machine. Okay, I'm here, I'm done. My apps install is finished, hooray. So now we have like everything. We have all of the CUDA toolkit installed. So if I now start Python 3 again, which is here, and let's import CuPy as CP. Let's create our array. And now if I square all of my numbers and have a look at x2, it did the thing. right? So this is just some very simple NumPy code using CuPy. So this operation happened on the GPU. Each one of the, this is an element-wise operation. So the GPU is this nice, powerful parallel processor that means that each operation will have happened at the same time, right? So 1 would have been squared, 2 would have been squared, 3 would have been squared. And now all of this works because when CuPy tried to do things, we didn't get an import error when we imported CuPy before, but when we actually tried to use it, it was like, I can't find the CUDA toolkit dependencies that I need. Okay, so common hurdle that lots of people fall into is not having those dependencies. Now, we can also install some of these rapids libraries that we talked about at the very beginning. So I'm going to pip install CUDF. Again, we have to specify we want the CUDA 12 version because pip doesn't know anything about CUDA and can't resolve that for us. So we'll download this from PyPI and install this in our environment. And then once we've got that, there we go, Python 3. Now pip's thinking about things. Right, if I run Python 3, we can then do some QDF code right here. So this is just creating a pandas series, basically, right? A QDF series, same API as pandas, and then doing just an apply on that. There we go. Import QDF, we'll apply. We do some data frame operations, and so this data frame operation was also executed on the GPU. Now, some of you might be thinking like, okay, you've done some stuff with pip. What about UV, right? UV is kind of the new, exciting, shiny tool for managing environments. So just out of curiosity, Naty, you said when you ran through this the other day, it had UV already. Oh, yeah, okay. They must have updated them.
Yeah.
So it already has UV.
Not all the machines do, so maybe people might want to check with UV. Yeah. In that case, they need to run that.
If you don't have UV, run this install script. And even if you do, you might want to do UV self update to make sure you're on the latest version of UV. But then you could do like similar things, right? So let's make a new virtual environment with UV and just explore with an environment in there. So let's make this sandbox directory and we'll cd in there and we'll do UV virtual environment create. We'll just pick Python 3.12. We can activate this virtual environment. And then we could do UV pip install QDF again. And it works exactly the same, right? We're doing UV pip install. You could also do UV add if you're doing like a project-based workflow, but it pulls in the same dependencies that we had before, maybe a little bit faster because it's UV. And then we could do the same kind of thing. So let's just do Python and run this similar example here. Yeah, so both of these situations that we've installed here, they needed that system CUDA toolkit to have all of the right libraries, just because of the way that pip works. We also have a little warning in here just about as we're developing these libraries, we're often installing like pre-release versions of these packages, trying out new developer builds as we're kind of making pull requests and building them. And there are some challenges around UV and pre-releases, so just highlighting those in case you want to try out newer versions of any of these libraries. So let's just deactivate our virtual environment again. We've covered pip and UV. Now in the what I'm going to do, I'm going to do a poll. I'm just going to say, which package manager do you prefer? We mostly hear people talk about pip, UV, Conda, and Pixie. I'm also going to add an other. So if you're like a poetry fan or something, then you can tick other. I'm going to click publish and then show on stage. So yeah, please do vote in this. Which package manager do you like to use for your Python projects? couple of pip UV people so far.
We cannot see the results, so I'm not sure if you see the same. Yeah, just in case. I don't know how that works.
On the stage, if I scroll down, I can see all of the different options.
See the voting part. Maybe you need to vote. I don't know.
I don't know.
To see it, I guess.
Try voting and see. I chose the option that said show the results straight away. Okay, anyway, of people answering, we've got mostly pip and UV people, maybe one Conda person. But this is an exciting opportunity for those of us that like Conda to talk about why Conda why Conda exists, why Conda is a thing, right? Like I think it's perhaps known as like the package manager that is preferred in like the sciences. I come from like a weather and climate science background, and like Conda was everything in that community. Bioinformatics, you'll find it. Robotics, you'll find it. And the reason that Conda like even exists in the first place is because of some of these limitations that pip has around compiled dependencies. Now, like if you go back years and years and years, pip just didn't support compiled dependencies, right? All it could do is pull in source code, and if it needed to be compiled, it would run the compiler on your machine. So if you want NumPy, you would have to compile NumPy. Everybody would have to compile NumPy when they ran it for the first time. Conda was created to solve this problem because I think the pip community at the time didn't want to solve that problem. Obviously, since then, a lot's changed. We now have wheels, and we can install compiled dependencies with pip. But it's still like Conda got like a big head start, right? Conda is very mature in terms of compiled dependencies, to the point where like you can Conda install Python, right? You can Conda install C++'s dependencies. You can Conda install R or Julia or like anything, right? It's just it's a binary package manager, which is different to pip, right? And pip and UV are trying to be the Python tooling, whereas Conda is trying to be the everything tooling for people primarily writing Python. But we'll see that because a lot of the time when you're working with a GPU, you need low-level system dependencies that are going to call to the GPU, like the CUDA toolkit dependencies. You're going to need higher-level compile dependencies like PyTorch or CuPy or QDF or whatever it is, and then your Python code sitting on the top. Conda fits perfectly into this situation. So I'm just going to run through a few steps on this machine to install Conda, just so we can have a little look and compare here. So I'm just pulling in this MiniForge installer. This is kind of the open source Conda implementation. It does.
I don't know if everyone else on the same, but I'm still seeing the poll. So maybe you need to switch to screen share or something.
Hide poll from stage. There we go. Okay. So I have run these two commands here from this cell. So if I just run down here, this just tells me that this is a BSD license thing, and installs a MiniForge. And then it says, do we want to auto-activate and do shell initialization? So I'm going to say, yes, please do my shell initialization. And I'm going to source the bash.c file. And so now you should see you've got this base here, right? And if I do which Python, I'm now in the like Conda base environment with Python. Now we can use Conda to create these same kind of environments, right? So we can do Conda create. I'm going to give it a name of rapids. I'm going to tell it which channels. So Conda has this concept of channels, right? So PyPI just has pip has one channel, PyPI. You can add extra indexes, but it has one channel. Whereas Conda has this concept of channels, right? So you can have different places can publish their own kind of builds of different things. So we're going to use the Rapids AI, the Conda Forge, and the NVIDIA channel. I think last I heard, actually, we don't need the NVIDIA channel anymore. But let's do this like this anyway. And we're going to say in our environment, we want QDF, we want Python 3.13, and we're going to tell it what the CUDA restriction is on this environment. And then we're going to activate this virtual environment as well. So if I run this Conda create command, Conda's going to go off. And this is completely ignoring kind of everything we've done up to this point. Right, so this is going to look for the Python packages we've asked for, QDF particularly in this case. It's going to pull in like a whole Python It will then be like cuDF needs all of these compiled CUDA dependencies. So we're also going to pull them from Conda Forge. It's going to ignore the like system CUDA toolkit. So that whole long CUDA toolkit apt install command that we had to do before that pulled in loads and loads of packages, this is just pulling in exactly what cuDF needs. Right? You can see some of these things in here, right? CUDA MVVM and MVCC. Right? These are some of the compiler tools, but those are used for, you know, if you write like a user-defined function in pandas, you write like a little function that you're going to like apply over a data frame. Right? If you do that on the GPU, that little bit of Python that you write needs to be compiled at runtime. So it pulls in all the bits and pieces that it needs for that. It's got its own like libcublas, it's got its own libqfft for doing fast Fourier transforms. Like all the different dependencies are all perfectly contained in this Conda environment. So when you create environments with Conda, they tend to be a lot smaller and they tend to be kind of more well contained and easier to reason about. So once we've got that, we should then, yes, it's activated. You see it's changed to say rapids now. And if I run Python, we start Python, and I'll just do a little bit of cuDF. Again, we're doing this like s.apply a lambda function because when we run this, like this will be compiled to GPU code when we call it, and then that apply will be, you know, doing a length on the different strings in our series, right? So we've done a little bit of GPU data frame operation. So we've done pip, we've done UV, we've done Conda, we've done a bit, you know, we use the system Python as well. We've kind of installed these tools in all sorts of different ways. If you're a Poetry user, like all the pip stuff applies. If you're into Pixie, then all the Conda stuff applies. Like all these different tools in those ecosystems can kind of map on. But it's worth understanding that there's these different layers of software libraries, right? You have the driver at the bottom, you have the CUDA toolkit dependencies on top of that, you have your Python dependencies on top of that, whether it's PyTorch or cuDF or CuPy, and then you have your code on top of that. You've got this stack. You need to make sure that you've got all of those pieces in order for everything to work together. And this is what these kind of managed platforms are providing for you, whether you're using like SageMaker or AzureML or Google Vertex AI, whatever it is. If you're getting like a working PyTorch environment from somewhere, like all of these things are being taken care of for you. But when you want to come and can set these up for yourself, it's useful to know like the kind of hierarchy of these things and where they come from. So like to recap that, I guess, like you install the driver, either the platform will give it to you or you run the runtime installer. Then you need CUDA toolkit. So you can either apt or yum or whatever install CUDA toolkit with your Linux operating system. Or if you're in a Conda world, like everything will just come bundled. And then in pip, you can pip install your packages, and Conda, you can Conda install your packages. And you'll get all those different pieces. So once you're at this point of having things installed, being able to import stuff, and being able to run a little bit of code, like this tutorial can go off in a couple of different directions. One is just like, how do we do, you know, some scikit-learn training or some pandas data frame stuff like with these tools. And in all honesty, like a lot of that kind of material we've done in the past and is teaching you stuff that you already know, right? If you know scikit-learn, that's great. You can use QML, like it's the same. If you know pandas, you can use cuDF, it's the same. If you know polars, you just need to know the like 2 extra flags to run the GPU stuff, and it's the same. So instead of going down that path and showing you kind of how to do these things you already know how to do, we're going to spend some time now looking into like monitoring and debugging. So when I run some GPU code, how do I actually, you know, there's a few questions you're going to ask, right? One is prove to me that I am actually running GPU code. I've done this a few times already. I did it right here, right? I imported cuDF. I created a series, which, you know, this will allocate some memory on a GPU. And then I did apply a lambda. This will do some compute on a GPU. But it just looks like pandas code, right? Like you have to take my word for it that it ran on the GPU. So like answering that first question of how do I know it actually ran on the GPU is, you know, it's a common thing that comes up. So let's have a look at a few little tools that we can use to get information out of the GPU and understand kind of what it's doing. The first one that we've already seen is NVIDIA SMI. This is going to show you a few things. It shows you information about the GPU, but it also shows you some information about the processes. And we don't have any processes at the moment. But if I got CMOX on here? Yes, I do. Right. I just split my screen in half. If I run NVIDIA SMI on this side, or I'm going to make it a little bit smaller just to try and fit NVIDIA SMI in the thing. I'll make it bigger again in a second. But just to show you NVIDIA SMI on this side, I got no processes. On the, sorry, I'm pressing all sorts of wrong buttons. Okay, if I now activate Rapids over here, and I start Python, and I do this same QDF command, right? We import QDF, I allocate some GPU memory, and I do that apply. I'm just going to leave Python alone now, right? It's just there, hanging out. I'll come back into the other terminal, and I'm going to run NVIDIA SMI again. Now this time, you can see in the processes, there is a process. Right? The process is called Python. It has a PID, and it is using 192 meg of GPU memory. So this is like the very first port of call where you'd be like, did my process actually like load some GPU libraries? Did it allocate some memory? Is it doing anything? What's my GPU doing? Can I see like, oh, the utilization is at 0%. That's fine. It's not doing anything interesting. But I could then like say I want to, if I do watch NVIDIA SMI, it will just keep calling NVIDIA SMI every 2 seconds. And then I swap over back to the other terminal again. What if I do while true f.apply that lambda? It'll do that over and over. That's not very hard. It's making the GPU do 1% utilization. Let's do something else. Let's import CuPy as CP, and we'll do array equals cp.random. And we'll give it a shape. Let's give it like 10,000 by 10,000 random elements. Random.random. Okay, so my memory usage just jumped up. Now I've got like a gig of memory used on the GPU because I allocated this big random NumPy style array on the GPU. Now if I do while true my array, let's just square everything in the array. And we'll just do that forever, right? Just keep doing that over and over and over and over and over. We can now see in NVIDIA SMI, the utilization is climbing up here. So we can see like, oh, I am now using the GPU. Even like squaring this is like the GPU is not finding that particularly hard. Maybe printing back to the screen is using enough CPU time that the GPU is not doing anything. There we go. Okay. If I just assign it back to a variable, the GPU utilization jumps up to 100%. The GPU is just there, chugging. All cores are just squaring numbers, and it's having a lovely time squaring some numbers there. So that's great. That's like our first little insight into what is my GPU doing. Now we can get all of these same metrics that NVIDIA SMI provides in the command line. We can get it through this library called NVIDIA MLPy. I apologize about the naming. This is like a historic thing. You have to pip install NVIDIA MLPy or contra install NVIDIA MLPy, but then you actually import it as PyNVML, right? It's actually the NVIDIA markup language, which is a way of querying driver information. But I'm just going to make that bigger again so you can see what I'm doing. Let's just have a look at this. If I pip install this into my conda environment, but hey, we can pip install that in there. And now if you have a look in Python, wrong way. If you have a look at Python here, I'm doing a few different things. Let's talk it through before I actually run it. I'm going to import PyNVML. Right, import this library, and we have to do PyNVML NVML init. This is just technically this is like an IO operation, so it would be bad practice to do this at import time, but it's like we have to just speak to the GPUs. So the first time you use PyNVML, you have to call NVML init. And then we can do things like we can say how many devices do we have? How many GPUs are there in the system? And it will print those out. Actually, let's just delete everything else. Just do that because, sorry, I should have pressed the other key to do this faster. But let's just get rid of all of that so you can see. We're going to see how many GPUs do we have? We have one GPU on this machine. We could do some other things. We can say like, what is the GPU's name? Like as in the, oh, I missed a step. We have to get, we get this like object that represents the GPU, and then we can query things about that. So we say, what is the GPU's name? Right, and it says, oh, this is an NVIDIA L4. That's good. That's what we chose in our Brev screen. And then we can query some of that same information, right? How much memory is being used? You say, I'm using half a gig of memory and I've got 24 gig of free memory. And you can query all the same stuff, utilization and whatever. So we often see people building their own little tools with this as well. If you want to monitor what's going on, or you want to record some of these metrics over time in the most kind of basic way possible. Now let's keep going. Now there is another tool that we often use called NV Dashboard. Now, the only trouble with this was my Brev instance was being silly, wasn't it? And it said failed up here and it wouldn't let me open the notebook. I'm going to try just manually clicking the link anyway. So if you scroll down, no, let me try it before I go actually talking you through it. No. Okay, that's irritating. Sorry about this. Usually when this starts up, we have Jupyter running on the system. Let me just have a look at. I just say it's running. Okay, I just can't access it because something went wrong with the build. Usually you can just click open notebook and it opens Jupyter. I'm just going to have to talk you through it and show you kind of screenshots and things, I'm afraid. If this is working for you, then great. Please do follow along with these steps in your own thing. But we have this tool called JupyterLab NV Dashboard. This is just a plugin for JupyterLab that shows you kind of, it's all the same information. It's built with this library, with this NVIDIA MLPy library. But it just shows some graphs. You can see over on the right-hand side here, there's like GPU utilization graphs, GPU memory usage graphs on the side. There's like a whole bunch of different things that you can do. So if this were working, you would be able to just deactivate all of your environments, Conda and pip and whatever you might have activated to get back to the system Python where Jupyter's installed. And you could do pip install JupyterLab NV Dashboard, and then restart Jupyter, and then opening Jupyter up through the Brev open notebook button would then show you the dashboard. So apologies that one's not working. But if you're a Jupyter fan, that's great. You can go and play around with that. Alternatively, if you are like a command line person and you want to do everything on the CLI, then there is also this nvtop command. This feels a lot like htop or btop or whatever your favorite top flavor is. Is that htop on here? Yeah. htop is the one I tend to run, right? It just shows you like all the processes on your system, how much CPU is being used. There's also, there's the old school top as well that just shows you like what are the top running processes on your machine. There is a GPU version of this as well. So if we apt install nvtop, might also be available as a conda package, I'm not sure. But if we install nvtop and then run nvtop, we get something that looks a bit like top. It's got a graph, it shows some processes. Again, I'm not doing anything very interesting at the moment. So if I, actually, I'm gonna kill it there. Let's open Python again. And make that size and kill that one and run nvtop over here. Right, got nvtop on the left. I'm back in my Python process on the right. Actually, let's just clear that. Python. Cool. Right, now if I do import CuPy as CP again, and r equals cp.random big array again. Okay, So importing CuPy didn't do anything, right? But then when we actually assigned some memory, our Python process appeared in NVTop. Right now, this is just because a lot of these things load lazily. So as soon as we try to do something, we're like, we need a CUDA context. We need to be able to allocate memory. We need to be able to call things on the and like CUDA stuff started happening, and so the process kind of appeared. And you can see as well, this little line has jumped up here, which is just showing like, we're using some percentage of our memory now. We've like allocated a gig of RAM or whatever size that array was. GPU memory, 952 meg. Right, and then if I do my same little, imagine I'm training a model or doing something more exciting than that, right? But if I'm going to run this, we can now see the utilization graph in NVTop jumps up to 100%. We can see like some memory is transferring back and forth between the GPU and the host, like all sorts of stuff's going on. We can see the temperature of it and how much power it's drawing. So NVTop is like a nice little tool. There's like a whole bunch of different things. You can use NVIDIA SMI, you can use the JupyterLab NV dashboard, you can use NVTop. There's lots of different ways of seeing what's going on your system. So let me just kill all of that. So that should start by like answering that first question of like, how do I know the GPU is actually doing something? How do I know I'm keeping it busy? Like I'm running some pandas code, I'm using the QDS plugin. Like, how can I see how well the GPU is being utilized? Is there any, is it wasting a lot of time on the CPU, or is everything being kind of well pipelined into the GPU? Okay. Now, before we move on, we've got 20 minutes left and we're going to start talking about profiling tools. Is there any questions, or does anybody want to ask anything about like, anything we've done so far, I guess, but like any of the install stuff, any of the monitoring stuff, either, ask in the Q&A or the chat. I guess while anybody might be typing there. Oh, I can hear a microphone. Is that you, Natty?
Oh, yeah. So I was just saying, I'm trying to start a new instance. And I think because we're on the same org, you might be able to get it when the Jupyter VM is. So as soon as it's up, then we can kind of go and then revisit the NV dashboard stuff. I'm just checking. I think still building, but.
Yeah. Okay, cool. All right, we'll see if that comes up. That's it. With live demos, you can never guarantee that nothing will break. Okay, so then the next question that we tend to have, right? Once we've figured out how to install things, figured out how to run some things, and figured out how to monitor a little bit, the next question is like, how do I kind of understand my code? Right? How do I understand the performance and how it's executing? And this is where you start getting into like profiling tools, right? How do I make sure I'm, maybe I'm looking at this graph and the GPU utilization keeps like spiking up to 50% and then dropping back down to 10%, and then spiking back up to 50% and then back down to 10%. Like, what's going on? Can I understand what's happening here? So we have a few different tools for kind of profiling your code. The first one that I'm going to show you is part of the Rapids ecosystem. So a lot of the libraries that we have, we've tried to build profiling tools into them. We have this in QDF, we have this in CuRML, and I think all of this should work in IPython. If it's not going to work in Jupyter, we'll see if that machine is.
It's up.
Oh, that says built.
So
okay, good.
Can you? Yeah, you should be able to access it.
Yeah. Oh,
so
it's going to make me
let's
log
see.
in.
Yeah.
Okay, you created it, but it doesn't let me access it.
Oh, that's so weird. Okay. Let me see. Can I give access to you?
I don't know.
Oh, I can add you as an user. Let me see. Add user.
Oh, yeah, cool. Okay.
Okay. Can you try now?
It still makes me. Don't make me log in again. Okay.
This is a beta feature, so we don't know if it'll work. But
yeah, we'll find out. No. No, okay, that's fine. Let's. Can we do this? You can use the magics in IPython, right? While that's solving, let's keep talking about these next steps. So, as we showed, like way back at the very beginning, we have this qdf.pandas library that can GPU accelerate pandas, right? And the way that we use this in a notebook, hopefully in IPython, is we do this load extension qdf.pandas, and then we can import pandas and do our kind of normal thing. Let's just run that like that. Into IPython, right? Can I run this in here? Okay, cool. So I have pandas as PD. Let's just clear that. Now, if I run this next bit of code, right, this qdf.pandas.profile, you would run this in a notebook. You'd run this like all in one cell, basically. This is the cell magic. I think I can use this in here. We're basically going to create a data frame, right? And we are going to just concatenate two of that data frame together. And then we're going to just call min on a couple of across a couple of different axes just to show you. And then we'll also do a group by. So just a few like simple pandas operations on this small data frame. If I run this, we then get this nice little printout, right? This will work in Jupyter or it'll work in IPython. It shows you, well, it runs this code, but then because we've got this qdf.pandas.profile magic at the top, it gives us like a breakdown of all of our calls here. So these are all of the function calls that were intercepted by the plugin and how long that they took. So it shows us the total elapsed time, how many GPU function calls happened, how many times it fell back to the CPU, so how many times it failed to do something, and it shows us like a full breakdown. Right? So we've got our kind of memory allocation call, our concatenation call. Those both happened on the GPU. We can see how long that took. We then called min, right? And it happened once on the GPU, and it happened once again on the CPU. And that's because of the way that we decided to collapse kind of row-wise and column-wise in the min here. And in QDF, this is only supported row-wise, right? Is that right? I think it's right. One of them falls back to the GPU because it's not falls back to the CPU because it's not possible to be done on the GPU. Now, if you just tried to do this in QDF, like you can, if you really want to, you can do import QDF as PD and use QDF as pandas, but that would have just failed. That would have just said QDF does not support this. Whereas by using the zero code change plugin, like it will just gracefully fall back to the CPU. And then we're doing a group by on this thing, so you can see there's like a group by and is getting the A column and doing a count, whatever. And all of that's happening on the GPU as well. So this is a really good opportunity when you're seeing maybe in any of these tools like NVTop, maybe that you're not utilizing the GPU heavily or at all. You can go in and run like a profiler like this and do qdf.pandas.profile and then see like, oh, is everything falling back to the GPU? Why is it falling back to the GPU? Can we go and have a look? This is telling me that this is not running because min fell back. Maybe it would also tell me that like this is not running because I'm trying to allocate too much memory and the GPU's run out of memory and so it's falling back to the CPU. There's like lots of different reasons why this would do that, and so you use this profiler to understand kind of function call by function call what's happening and why it's falling back.
you should be able to access the Jupyter link now.
Okay. Not the Colab one. Brev.
If you scroll down
And refresh the page. Click Open Notebook. Ah, hooray! Cool, awesome. Okay, so this is on your instance, isn't it? Though? So
yeah. You might need to install something.
Yeah. Just do Python-m pip install Jupyter Lab NVIDIA dashboard. Maybe it's just that way. Okay, and then it was system control restart. Which will kick me off here for a second. Sudo. Yeah, okay, so that died, but it should come back in a second. Aha, cool. Okay, that worked. So after I've installed that here into Jupyter, I pip installed NVIDIA dashboard. You can now see over in the left-hand side, there's this nice little GPU icon here. And you get this drop-down list of all these different dashboards that you can see. So you can get like memory graphs, you can get utilization graphs, you can get the full resources, right? How much the GPU is used to memory, how much data is moving back and forth between the GPU and the CPU. Or if you have more than one GPU, you can also see like the NVLink connection, how much throughput is happening between the GPUs. Maybe you're like serving an LLM or training a model that's using multiple GPUs, and there's lots of communication going back and forth. And you can grab, it's Jupyter Labs. You can grab these and rearrange them and set up your dashboard however you want, and have your notebook and have your little plots kind of running around everywhere with you in here. So my little claim to fame actually is I drew that icon of the GPU in Jupyter. Why are you making me leave the site? Yeah, leave that site. Yes. Okay, cool. Thanks for sorting that out, Natty. That it's good to be able to show that. Now we've got 10 minutes left of the tutorial. And the last thing I want to show you, if I get my browser back to the right page again, if I just head back to the material, the last little thing we're going to talk about is this Nsight systems and NSys. Now, historically, this has been the tool that like C++ developers would use, like CUDA developers who are working on these low-level libraries, like the people that are building CUDA Toolkit, or the people that are building PyTorch or Rapids or whatever. But over the last few years, like Nsight has got really great support for Python, and it can show everything now from Python all the way down to like low-level calls in the CUDA stack. Now, there's kind of two halves to this tool. There's one part just called Nsight Systems. And if we click this link here to go to the Nsight page, you see it shows here, right? Download NVIDIA Nsight Systems, and it shows you how to download it for Windows, Linux, or Mac. Right. Now, this isn't because we can run CUDA code in all these places, right? You can't run CUDA code on a Mac. But it does have, like, I'm a Mac user, and it does have like the front end, right? The desktop application of Nsight Systems available for Mac. So I would come in here and click download Nsight Systems for Mac. Equally, you could come in and download it for your Linux system or your Windows system. This is like a, this is a big desktop client, and it's very powerful and it can do all sorts of different things. But the main thing that I see people using it for in the like Python space is to run some kind of profile somewhere on some other remote system, and then use Nsight to open that profile. Right. So if I grab this little script here, which is the kind of doing the same thing we were doing before, but we're going to put this in a Python script. So instead of using the like Python magic to install the cuDF pandas thing, we're going to do the Python script version just for completeness. You'll have seen all the versions of this now. But if we do import cuDF.pandas and cuDF.pandas install, and then we'll just do our same little bit of pandas code again. So if I copy this, let's go back into my terminal and just, what is it, my script.py. Just paste this in here. Now I should be able to just do Python myscript.py, right? And it won't, it'll think about it for a second and it's completed, right? It's run my code. I might even put a little print counts or something in there so we can see it actually doing something. There we go. Okay, so it runs some code. It runs on the GPU. We could view NVTop or something to check that it is running on the GPU. But now there's another tool installed, and because this tool comes with the full big CUDA toolkit that we installed before with apt, right? It's called NSYS. So I have a look at NSYS. I have NSYS installed. NSYS is the profiler for our applications. Now you can do all sorts of different things with NSYS. I have like an example command here. Right, we're going to do NSYS profile. We're going to say like trace all of the CUDA code, all of the like intermediate compiled steps we might have, or any compilation that's going to happen. Without getting too deep into how all that works, we just want to track all of these things. We're going to track all of the GPU device metrics, right? Because we care about those. We want to track memory usage. We'll overwrite the file if it already exists, and we will output it into a file. We'll call it profile run v1. Now, I kind of explicitly, I'm going to run this with sudo because I need to be able to query some like quite deep down stuff in the GPU driver, or NSYS needs to speak quite deep down into the GPU driver. So you have to run this with sudo. So we should just make sure that it calls the right Python, whichever Python you have activated, whether it's a UV virtual environment or whether it's a pip virtual environment or Conda or whatever. Let's just make sure we don't make that mistake. So I think I'm still in the Rapids Conda environment. It will still work. Let's just copy that properly. Paste. Now, if I run this, we see a little bit of information from NSYS. It's going to call my script. We then print out the same data, and then it gets like a big dump of information out from the GPU of what happened in that time, and then it like pretties that up into this nice little report. So we get this profile run v1 nsys.rep file. Now I need to download this. Normally I would do this through the Jupyter UI actually. I think I already have one downloaded on my Mac, so that's fine. But what I'm going to do now, so for the next step, now that we have this file, we've generated it with NSYS, we need to open it in the viewer. So I've already done this, but you would come in and say on Mac OS, download the application and install it. So if I go to applications and go to NSYS, Insight Systems, there it is. And this should open up in a new window for me. There it is. And then I can open up this profile. Imagine, you would go and download it, right? I think if you were running this in Jupyter, you would see it in the file browser, and I would just download it to my system, which is what I did with these. Again, sorry that the Jupyter wasn't working properly. But then what I would do once I've downloaded it into downloads, I would go like File and Open, and then choose that file that I've downloaded. Now there's all sorts of other stuff you can do in here. You can set up SSH connections and like launch jobs from this UI and do all sorts. But I'm just going to open up the report here, and this just shows me a timeline. Let's make these things a bit smaller so they get out of the way. This shows you a timeline of all of the execution of that script. So from the beginning of NSYS running, we've got the GPU starting up because NSYS was probably talking to it. Got all of Python, right? You see the Python process in the middle here. This is like Python starting. Python obviously it has this reputation of being a slow language, so there's like a whole load of startup overhead for the process to start. And then around here, we're actually starting our code. So I'm just gonna hold Command on my Mac and zoom a little bit just to make this a little bit more clear what's going on. We can see basically here is where our script started executing. We have this data frame underscore init call, right? When we created our, let's just have a look at the script, remind ourselves of the script. Here, right? Small df equals pd.dataframe. If we go back to NSYS, we can see dataframe.init got called. QDF.pandas executed this fast, right, on the fat slope proxy. And we can see under the hood, like, oh, this is calling, this is creating like an arrow memory, PyArrow memory object, and creating like, a column in the GPU, and all these different function calls are happening. You can kind of drill right down into everything that's going on in here. Then the next thing that happened was this dataframe.concat internal function was called. That happened fast through the fast slow proxy. And we can see, right down to the CUDA API, what CUDA API calls happened. There's this is our kernel launch, right? How long it took for the CPU to say to the GPU, like, can you do a concatenate for me? The GPU starts doing it. It allocates some memory because the concatenate's got to go somewhere. And then it does the actual concatenate. Remember, these are tiny little toy examples. So it spends a load of time allocating memory to then just actually concatenate two things together. At the end of the concat, then we did this min here. This is the first min. And we're doing like a data frame reduce. This is calling down into CUDA again. You can see all these little CUDA operations that are happening down on the GPU. And then we can see we hit this slow call because we can't execute that one. And then because we executed on the CPU, we have memory on the CPU, so we have to copy back to the GPU. And you can kind of really drill down into what's going on in the application here. You can get all sorts of information about how busy the GPU is, how much memory was being used, etc. So this is the super ninja tool. Once you're really getting deep into developing with GPUs and you're using these tools kind of in depth and all the time, and you want to understand performance characteristics, you can go all the way down as far as Nsight and really drill down into what C++ functions were being called when I did this thing. But for beginners, you would start right up at I'm going to do NV-top. I'm going to use Jupyter NV dashboard. I want to see my utilization and my memory usage and make sure I'm actually using the GPU. So that's it. That's perfect. That is basically the end of the tutorial. We've got 2 minutes left. I haven't seen any more questions come in. If you do have any more questions, please do put them in the chat, and we can answer those. But this hopefully has given you a bit of an understanding of installation, monitoring, some debugging. The main thing our team is always trying to answer is this is great. In a 90-minute tutorial, we've gone through in a very controlled environment, right? A VM that we know and understand. Even then, it's kind of a bit funny, isn't it? But on a VM that we fully understand, this is how you set everything up. The immediate next question is well, what about Databricks? What about Coiled? What about Snowflake? What about whatever your organization uses? How do you use these tools? That's kind of the focus of our team at NVIDIA. So we're constantly working on new material. You can go and find links to all of our material from here, some of the pages linked. So say you're a Databricks user, we have a page on Databricks, how to install, how to set things up. If you're a Azure machine learning user, we have a page. We spend a lot of time documenting and trying to understand all the different platforms, whether they have all of these things installed out of the box, whether you need to add stuff that's missing. How do I launch this? How do I launch that? How do I run the profiler? How do I, we're trying to answer all these questions so that you can get up and running kind of as easily as possible on whatever platform you prefer. So yeah, thank you all. Thank you everyone that's come to the session live. Thank you to everyone that's watching the replay throughout the week. And yeah, Natty just asked in the chat, is there anything else that anybody would have liked us to cover in this? If you do have any thoughts on oh, I really wish they talked about this topic or that topic within the context of this, deployment, tooling, installation, Python, GPUs, please do put it in the chat. We'd love to kind of keep improving this documentation and tutorial and things over time. So with that, I'm going to stop screen sharing. Thank you all for coming and have a good rest of the conference.
This was amazing. Thank you so much, Jacob and Natty, and to all the attendees that joined us. We can always continue the discussion in the Discord. Also, a recording of this session will be available shortly for rewatching. And thank you so much.